Hey everybody, we're going to be starting Module 8 now. Just to let you know, there are some topics in Module 8 that we are getting rid of. So let's start with the first topic, the square root of a rational perfect square. When we're talking about perfect squares, we are talking about 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, so on and so forth. So we're talking about the numbers 1, 4, 9, 16, 25, 36. Then 7 squared would be 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, and we'll stop there, okay? So this first example where we have the square root of 12 over 75. 12 and 75, you don't see them in this list. But if I simplify the fraction 12 over 75, 3 goes into each of them. So this would become, instead of 12 over 75, this would become 4 over 25. And as you can tell, 4 and 25 are both in this list. So when you have a fraction underneath a square root symbol, what you can do is you can change it to a square root divided by a square root. So the square root of 4 over 25 would become the square root of 4 divided by the square root of 25. And the square root of 4 would be 2, because 4 is 2 squared. And the square root of 25 is 5. So our answer would be 2/5. So we simplified the fraction, and then we broke it into 2 square root problems. Down here, we have the square root of 36 over 100. We can simplify this first, or we can just break it up into the square root of 36 over the square root of 100, because 36 and 100 are both perfect squares. The square root of 36 is 6, and the square root of 100 is 10. But we are not done because we have to write it in simplest form. So what goes into 6 and 10? That would be 2. So this would become 3/5. If we simplified 36 over 100 at the beginning to get 9 over 25, we would end up with 3 over 5 as well. Okay, we'll move on to our next problem. Okay, our next topic, square roots of perfect squares with signs. Okay, so we're going to be looking at the difference between having a negative on the outside of a square root versus having a negative on the inside of a square root. I believe we did this in MAT137 or something similar to it. This -1, or this negative on the outside is really a -1. So this is really -1 times the square root of 64. So this would be -1 times the square root of 64, which is 8. And that would be -8 would be your answer, okay? That's when we have a negative on the outside of a square root. When you have a negative on the inside of a square root, you cannot take the square root of a negative number without using imaginary numbers, which we are not going to get into. So the square root of -49 would be not a real number. So not a real number. So a negative on the inside is no good. A negative on the outside is good. Okay. You just have to treat the negative on the outside as a -1. Our next topic, simplifying the square root of a whole number greater than 100. If you had a calculator and you did the square root of 175, it would not come out to a nice number because 175 is not a perfect square. So what we have to do is we have to simplify the square root. To me, the easiest way to simplify a square root is for you to find a perfect square, the largest perfect square that goes into it. So those numbers that we came up with before, the 1, 4, 9, 16, 25, 36, 49, then we have 64, 81, and 100. We have to find the largest perfect square that divides into 175. Having this list next to you is really going to help, okay? So I like to go and start with the highest one, right? Do you think 100 is going to go into 175? No. Is 81 going to go into 175? You can simply just divide 175 by 81, and it does not go in evenly. Does 64 go into 175? No, it does not. Does 49? No. Does 36? No. Does 25? So 175 divided by 25 would be 7. So I would write this as the square root of 25 times the square root of 7. Okay, 25 is the largest perfect square that divides evenly into 175. You want to find the largest. So the square root of 25 is 5. And the square root of 7, well, 7 is not a perfect square and it's a prime number, so we bring that down. So the square root of 175 is really 5 times the square root of 7. Okay, you want to make sure you're pulling out the largest and not just any one, because you're going to be left with something that can be simplified again. If you pull out the largest, you're going to be left with a square root that can't be simplified any further. Okay, let's go over to the square root of 192. The square root of 192, if you look down the list, 81 actually goes into it even. Okay, so we're going to make this the square root of 81 times the square root of 2. The square root of 81 is 9, and 9 times the square root of 2. And the square root of 2 can't be simplified any further. Okay? Now we go to the square root of 124. Okay, looking at the square root of 124, it may look and appear that a large number would go into it. My first impression is that 64 would go into it evenly, but it does not. So we went down a list. 64 doesn't go into it, 49 doesn't go into it, 36, 25, 16, or 9, but 4 does. So this becomes the square root of 4 times the square root of 31. The square root of 4 is 2, and 31 is a prime number, so nothing else is going to go into it. So the square root of 124 becomes 2 times the square root of 31. Now we're going to be talking about the Pythagorean theorem. Pythagorean theorem is something you've been doing probably since middle school. All right, it's when you have two sides of a right triangle and you want to find the third side. What's important to know is that the legs of your right triangle are either A or B. These are interchangeable, but your hypotenuse, the side opposite the 90-degree angle, is C. And then the Pythagorean theorem states that a squared plus b squared equals c squared. Right. In these two problems, we are missing the hypotenuse. So we have our two legs of 5 and 12. So we are going to say that 5 squared plus 12 squared equals c squared. And 5 squared is 25. 12 squared is 144. And we have to look at c squared. 25 plus 144 is 169. And then to get c by itself, to get that square away, I have to perform the opposite operation of that, or the inverse operation. So I'm actually going to be taking the square root of each side. Now a square root cancels out a square, and the square root of 169 is actually 13. So our hypotenuse would be 13. Okay. Over here, same thing. We have our two legs. We'll make A be 7, so 7 squared. B, the other leg, it would be 24. And we're looking for our hypotenuse, which we'll call C squared. So 7 squared is 49 plus 24 squared. Let's grab my calculator real quick. 24 squared would be 576. And then 49 plus 576 is 625. So 625 equals C squared. And then we can't forget to take the square root of each side. And the square root of 625 is 25, I believe. Let's double check that. It is 25. Okay, so we are looking at our hypotenuse of the first one on number 4 being 13 and the hypotenuse being 25. Okay, now we are going down to our next topic, which is just the Pythagorean theorem. We are asked here to round your answer to the nearest hundredth. Hundredth would be 2 decimal places. Okay, and we have to make sure that we round correctly. All right, the only difference here in these problems is I'm now missing a leg and I have a hypotenuse. So I still have a squared plus b squared equals c squared. All right, but this is going to be x squared, or I can leave it as a squared, plus 10 squared equals 14 squared. So now I square what I can. X squared stays. 10 squared is 100, and 14 squared is 196. Okay. Now to solve for x squared, we have to subtract 100 from each side. So x squared equals 96. Now to get x squared by itself, I have to take the square root. Now instead of simplifying it like we did a couple topics ago, it just wants us to round it to the nearest hundredth, so 2 decimal places. So x would equal, and I type the square root of 96 into my calculator. I get 9.79795, blah, 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 blah. But I only want to round it to 2 decimal places, okay? So I take a look at the third decimal place. If the third decimal place is 5 or larger, I need to round this up. So this is 7, so that's a 9. I need to bump up 9 to a 10, which actually then would make this 7 and 8. So this would become 9.80 for your answer. Now, Alex is definitely going to want you to type in 9.80, not 9.8, not 9. It would have to be 9.80. Make sure you're not truncating, which is just chopping it off. You are rounding, which is 5 or above. You're going to move that second decimal place up 1. Okay. Same thing over here. For this next problem, we have x squared plus 8 squared equals 10 squared. So x squared plus 64 equals 100. And then we have to, I went off my page there, 100. So then we have to subtract 64 from each side. So x squared equals 100 minus 64. In this case, it's 36, and that's a nice number because when we take the square root of each side, 36 is a perfect square, so that's just 6. Sorry about that. We had the leg being 6. Now we don't have to round that because it's just 6. Okay. Moving on, we have word problems of Pythagorean theorem. Now, I know word problems are a bit scary and you don't like word problems, but I promise you these problems aren't too bad because they're already going to give you the picture label. So they're telling us a 35-meter tall building casts a shadow. The distance from the top of the building to the tip of the shadow is 38 meters. Find the length of the shadow. Okay. If necessary, round your answer to the nearest tenth. Tenth is 1 decimal place. Okay. So here they're giving us a leg and the hypotenuse. So this is going to be 35 squared plus x squared, which would be the other leg, equals 38 squared. Now we could put x squared here or 35 squared here. You can interchange these, okay? Either way, we're gonna have something set up just like that. So now we have to do 35 squared. 35 squared is 1,225 plus x squared equals 38 squared, which would be 1,444. Now to get x squared by itself, I have to subtract 1,225 and 1,444 minus 1,225 would give us 219. So x squared equals 219. To get x by itself, I have to take the square root of each side. So x would equal the square root of 219. So to take the square root of 219, I would get 14.7986. Boom, boom, boom. But it only wants it rounded to the nearest tenth, so 1 decimal place. Our second decimal place is 5 or above, all right, it's 9. So we would say the answer would be 14.8 meters, okay? So 14.8 meters would be the length of that shadow. All right, let's move on to the next word problem. It says a 10-foot ladder leans against the side of a house. The bottom of the ladder is 5 feet from the side of the house. How high is the top of the ladder from the ground? If necessary, round your answer to the nearest tenth. So we have our leg of 5. I have our hypotenuse of 10. That would be the ladder. And the height of the building would be our unknown. That would be our other leg. So this is going to be x squared plus 5 squared equals 10 squared. So x squared plus 25 equals 100. And we would subtract 25 from each side. So x squared equals 75. And then x would equal the square root of 75. And the square root of 75 is 8.66025, but they want it rounded to the nearest tenth. And then once again, our second decimal place is 5 and above, so we round this up to 8.7, and that would be 8.7 feet would be the height of that wall, okay? Now, if you notice, this next topic has a big arrow through it, right? We're not doing this topic. This was taken out by Gateway, all right? Because of the whole distance learning thing and us having a lack of time to do this, okay? So we are going to be moving on from here. Okay, our next topic we're going to get into is we're going to start talking about introduction to simplifying a radical expression with an even exponent. So we have a square root and it has an even exponent underneath that square root. We're going to talk about what that actually means. So this is a square root. I know we don't write it. You don't usually write it when you have a square root, but there is a little 2 out here that's supposed to be there. So we have the square root of x to the 36. Now what you want to do here is you want to make this into a fraction. So we're going to do 36 divided by 2. So the square root of x to the 36 is going to be the same thing as x to the 36 divided by 2. So you are dividing your exponent by the number on the outside of it. So in this case, when you don't see a number, there's a 2. So the square root of x to the 36 is really x to the 36 over 2. So 36 over 2 is 18. That's going to be an exponent, right? So it's x to the 18. The way I could describe this to you is if we look at the opposite of it. If I had x to the 18 squared, if you remember the power to a power property, you would be multiplying the power. So this would be 18 times 2, which would be x to the 36. If we did the reverse of it, we're actually dividing the exponents. So the square root of x to the 36 would be 36 over 2. So if we took x to the 18th and squared it, it would be x to the 18th times x to the 18th, and then that would be x to the 36th. So we are dividing our exponent, so we're looking at x to the 18th. Okay? That makes the square root of w to the 20th pretty easy. So w to the 20th would really be, or sorry, the square root of w to the 20th would really be w to the 20th over 2, which is w to the 10th. All right. We're going to expand on that down here because we're mixing regular numbers, all right, whole numbers with our exponents. So we have here the square root of 9w to the 14th. So I'm going to break this into two separate things. I'm going to make this the square root of 9 times the square root of w to the 14th. Okay, the square root of 9 is easy. We've done that before. The square root of 9 is 3. The square root of w to the 14th is really w to the 14th over 2. Now 14 over 2 is 7, so this becomes 3w to the 7th. I don't have any square roots left. All right, this is the square root of 9, and the square root of w to the 14th is 3w to the 7th. Our next one, very similar. We have the square root of 9 times the square root of w to the 8th. All right, this would become 3, not w, y to the 8 over 2. So this would be 3y to the 4th. Okay, when we have the square root of 16z to the 4th, this becomes the square root of 16 times the square root of z to the 4th. And the square root of 16 is 4. And the square root of z to the 4th becomes z to the 4 divided by 2. So that would be 4z to the 2nd. Okay? Next, we're going to be talking about cube roots of an integer. You're going to notice in the first problem that we have the cube root. We have a 3 here. So that's the cube root of negative 216. So what we're really trying to do is we're really trying to figure out what number cubed, so what number to the 3rd power. So x to the 3rd, when would that be negative 216? So what would that value of x be? Now, another thing that you might realize is that we have a negative underneath the cube root. So your first instinct would probably be to say that there is no answer to this. Those rules only apply to when we have an even number out front. So a square root, you can't take the negative of because a number squared is always positive, but a number cubed could be negative. We'll talk more about that later. If you have a calculator or a calculator app, finding the square root or finding the cube root could be a little confusing to you. So I want to go over those steps. On a graphing calculator like this, it works the same way even in the apps that I gave you that I posted. If you hit math, the math button right here, and then you scroll down to number 4, it already has the cube root in it. So if you select number 4, we have the cube root of, and it gives you a little square. We have to enter in -216. Now the cube root of -216 is -6. Now let's talk about how it can possibly be a negative number. Because you were always trained when you take the square root and get a negative out, it really can't be, right? Or if you're squaring a negative number, that it should always be positive, but we are cubing it. So we're looking at -6 cubed would be -6 times -6 times -6. Now a negative times a negative would be a positive, then a positive times a negative would be a negative again. So the cube root of a negative number can actually be taken and it would end up being -6. Okay. The same thing over here. We're looking at the cube root of 27. So I hit math, go to option number 4, and then I want to enter in 27 and hit enter. So the cube root of 27 is 3. All right, so to explain that, 3 cubed would be 27. Okay, so on our next topic, finding the nth roots of perfect nth powers with signs. All right, what they want us to do is they want us to evaluate the 5th root of -32. And it says click on not a real number if applicable. So just like up here, your first instinct would be to take the taking the 5th root of -32 would probably be to write not a real number. Because this number on the outside is odd, it's possible for you to take the odd power root of a negative number. So how would you do this on a calculator? How would you enter in that 5th root? So let's figure that out. If we hit math and we look at option number 5, option number 5 has an X in front of it. So if we choose option number 5, we are going to, you see we have 2 little squares that pop up. I need to fill in those numbers with 2 numbers. So we have the 5th root, right? And then if I hit right, I can go on the inside, and then I have to hit -32. Okay? So that would end up being -2. Okay. Some calculators don't work as well as this with the little squares. Let me see if I could show you if we don't have a nice, let's figure this out. Let's go into classic maybe. If I hit math and I choose this, oh yeah, see how it just comes up? It doesn't come up with the squares. I just have an X out front. All right, here's what I'm gonna have to do if you have a calculator. It just gives you that X. So that would, I'd have to enter in that root first. So I'd have 5, and then I hit math option number 5. So I'd really have 5x, the square root, and I'd have to enter in -32. Okay, that 5 counts as that root. So I have the 5th root of -32. This is if your calculator doesn't give you the boxes. You'd have to type 5, then that xth root of -32, get the -2. Okay? Okay, this next problem, B, part B, we have -4th root of 256. Now the negative's on the outside, so I can take the fourth root of 256. So this would become -1 times the fourth root of 256. Okay, so the fourth root of 256, we could hit 4 for the fourth root, and then we have to go to math, and then option number 5. So we have the fourth root of 256 is 4. So this would become -1 times 4, which is -4. Okay. Next, we have -4th root of 16. That would be -1 times the fourth root of 16. And the fourth root of 16. So 4, math, option number 5 of 16 would be 2. So this is -1 times 2, which is -2. And then we have the fifth root of -32. The fifth root of -32. So we have 5, and then we find the xth root of -32, and that would be -2 as well. Okay, so when would you select not a real number? You'd select not a real number is if you had a negative number on the inside of an even root. A negative on the inside of an odd root is okay. A negative on the inside of an even root is not. So for example, if you had the fourth root of -16, if that negative was on the inside, the fourth root of -16 would be not a real number. Okay. Same thing here. This kind of combines with the first topic we talked about in this video. We have the fourth root of 16 over 625. This would become the fourth root of 16 over the fourth root of 625. That 4 should be not next to it, but kind of inside this little loop. Okay, so the fourth root of 16. So 4 times math, or not 4 times, 4 math, option 5 of 16 is 2. And the fourth root of 625 would be 5. Our answer would be 2/5. Now we're looking at the cube root of 1 over 27. So this would become the cube root of 1 over the cube root of 27. And the cube root of 1 is 1, because 1 times 1 times 1 is 1. And the cube root of 27 is 3. Because 3 times 3 times 3 is 27. Our answer would be 1/3. Okay. Now the last topic on this first half of the Module 8 worksheets is we are finding the nth root of a perfect nth power monomial. Okay, so we have the cube root of 8x to the 12th. So I'm going to break this into the cube root of 8 times the cube root of x to the 12th. Now the cube root of 8, so a math, number 4 gives me the cube root of 8 is 2. Okay, then we have the cube root of x to the 12th. When we have the cube root or any root of an exponent, this becomes x to the 12 divided by that root. So x to the 12 over 3. So this would be 2x to the 4th. would be our answer. Okay. Our next problem, we have the 5th root of 32w to the 35th. So that would become the 5th root of 32 times the 5th root of w to the 35th. So the 5th root of 32. So I want to enter 5 math. Option number 5, that's going to give me the 5th root of 32 is 2. Okay, so this would be 2. And then the 5th root of w to the 35th is w to the 35 divided by 5. And 35 divided by 5 is 7. So we have 2w to the 7. Okay. Our last problem is we have the cube root of 27x to the 18th. So this is the cube root of 27 times the cube root of x to the 18th. And the cube root of 27, we look over here, the cube root of 27, we choose option number 4 for the cube root of 27 is 3. And then the cube root of x to the 18th is really x to the 18th divided by 3. So this is going to be 3x to the 6th. Okay. So that is the first half of Module 8. I will be posting the second half of Module 8 tomorrow for you. Okay.